today, what is our Meteorology Minute?
Meteorology Minute, I was thinking we do the 3 things that you need to make up a front.
Ooh.
Because everybody hears on the news, they're like, oh, there's a cold front coming. There's a warm front coming.
But what does that
We've got
mean?
a front coming. But what does a front look like? Like, how could you figure out on your own if there was like a cold front coming, for example?
So everything, let's back up a little bit. Everything in meteorology is like a recipe. It's like a recipe card. Like if you've got all the ingredients, it will happen. So when you think about a front, what are the ingredients for a cold front, Jenny?
So I don't know if it's necessarily cold front, but I'm just going to start with like front, just in general, front. So you've got to have a wind shift. So your winds have got to turn.
Of how much?
Significantly. I don't remember the degrees. What is the degrees?
You're teaching people in the Meteorology Minute. We got to look this up.
I just remember wind shift. I don't remember the exact degrees.
Anyway, keep talking.
But wind shift is one of the big ones. You also need a change in temperature. So your temperatures need to change, which seems pretty obvious. If you're getting a cold front, it's going to start warmer and then get colder as it passes. And you also need a pressure change, because usually you're going from high to low pressure or low to high pressure. But those are the 3 things: wind shift, a temperature shift, and a pressure shift.
Well, you get the pressure shift because of the wind. We talked about that on the last
we did talk about it
Meteorology
yesterday. But I just remember those were the 3 that like, and it depends kind of like on what map you're looking at. So there are different maps where it'll show you, just pressure, just temperature, just wind. But it's really nice when you can get all 3. And if you're having a hard time, like being able to tell if the winds are shifting enough, then you can just go look at the pressure. Be like, oh, well, is the pressure decreasing for me? Because that'll kind of, point me in the right direction.
Yeah. So we got a question. The lines with the triangles. Yes, the blue one is usually a line with triangles on it. That's a cold front. And the definition of a cold front is a wind shift. It doesn't necessarily need a temperature change, but usually if the wind is shifting that much, that there's usually associated a temperature change, but not always. So then the red one is a warm front.
That usually has the
it's
little
red
half
with
circles.
With the half circles, that's a warm front. Again, it's not always going to be warm air moving in, but usually it is. And that's also a wind shift. And then there's the thing called an occluded front, which is just above the level of the Meteorology Minute.
Yes, that's a little advanced.
It's 2 different air masses that are just like chilling next to each other for a little bit of a time.
It's usually you get those once a storm system is like starting to die out, like after it's finished its strongest run.
Correct. Temperature is a symptom, not a cause. So it's just it's a wind shift is how you define a front.
Yep.
And then if you get any temperature change out of it, that's just bonus nachos.
Yep. That can definitely help you try to like find a front, though. If you look for different like temperature changes, you're like, oh, maybe there's a front there. It looks like the temperature's
So way back in the day, like before computers and everything, like the meteorologists would call all the weather stations in the country. There'd be like a big phone call or whatever. You'd like, send your information, your weather station via radio or telephone. And you would plot all of it on a big map every single day, big paper map or big whiteboard with grease pencils, and you'd mark everything. And then once you got all the temperatures and the wind speeds and everything, you could see a shift in the towns. So you'd look across the United States or whatever, and you'd see, oh, their wind is all from the west and their wind is all from the north. There must be a cold front right there. And then you draw your lines and all that. So but now that we've got computers, it's a little bit easier to visualize it. We've got computer models that like calculate all this stuff that can predict it all.
They can find the fronts for you.
Ooh, yes. Windy is a great app to see temperature and wind changes. So play around with that. Look at the winds at different heights and stuff. I was just on Windy yesterday. It's a good app.
Yeah.
It's a really good app. But it's not perfect, though. It uses the computer model. It doesn't use real data. It uses the computer model's estimate of what the data is going to be.
Yeah.
It's a forecast product, basically. So just keep it in mind. It's not perfect. But yeah, it's a really good way to visualize it.
During hurricane season, too, if you zoom out and you go over like to the Atlantic or the Pacific
Basin,
you can see them
around
as they spin up. So interesting to watch. But yeah.
Thoughts on wind from renewable energy? I don't know much about it. Yeah, I mean, like, we're getting there. I mean, like, all these newer technologies are going to take decades and decades to refine and get to their final form. A lot of people like to poop on them now because they're inefficient and they take a while to pay off. But like, we got to pay our dues, so to speak. I mean, the first gasoline engine, think about how much gasoline the first gasoline engines wasted. They weren't getting 80 miles a gallon like the hybrid cars are now.
Yeah.
So it's going to take a long time for us to get renewable energy to where it's optimized, it doesn't harm the environment as much, and it gets to be more useful than it is costly. But we just got to do the 40, 50 years of research and development before it gets there. And a lot of people aren't willing to be patient about that. So that's my hot take. I don't really have a hot take. It'll get there. Be patient. We're working on it, okay? Just like the morning show.
Yes.
We're working on it.
Yes, yes.
I'm excited. So, how can they get forecasts wrong 50% of the time? So that's a fun statistic. I'll rant about that for a second. I would say 99% of the time, whatever the forecaster has forecasted happens. It just doesn't happen at your house.
Yeah.
If they forecast for rain, it probably does rain. It just doesn't rain right on top of your house. And everybody is looking for a pinpointed forecast from their own like 6-foot circle around them.
Right.
But that's just not how weather works. Like, we know it's going to rain, but exactly where it's going to rain, it might be off by 5 to 10 miles. And if it like literally like the standard of from the public for a forecast is impossible, because if it rains at your house and it doesn't rain one street over, they're going to be mad if they forecasted rain. You know, there's like this whole bias system of like, people are going to be really unhappy if it rains when you didn't say it was going to rain, but they will be overjoyed when it's sunny if you forecasted rain. So there's a whole lot of bias going into it and all sorts of other stuff.
I think I know what our next Meteorology Minute is going to have to be.
Yeah.
Yeah.
Yeah. How to do, percentage.
Yep.
Yeah. So, yes, Happy Trees is correct. That will be the next Meteorology Minute.
Yes.